Hi, this is Ms. Smith from Enrichology Tutoring. I'm making a quick video going over how to simplify an expression. Is a fraction bar. Of course, it's this little bar in the middle. Whenever we see it, we know that we're dealing with a fraction, which is also just division. So in the end, some of these we indeed will be dividing to come out to a single solution. This first problem is relatively simple. Now, when we do this, we look at the numerator, which is the top part, and the denominator separately. And we don't put them together until the very end when we're dividing the terms. On this first one, a common mistake that I see students sometimes do, as I'm about to write, don't do this. I'll see them do 48 divided by 12 plus 36. Of course, 48 divided by 12 equals 4 plus 36 equals 40. The correct answer is 40, right? No, the answer is not 40. What we're going to do is we did not divide the 36 by 12, and we need to do the 48 by 12, which is why we're going to solve or simplify the numerator first and then divide it by the denominator. Simplifying this, we get 48 plus 36. Let's see, 40 plus 30 equals 70, 84 over 12. And then from there, we do divide 84 divided by 12. Let's see, 12 times 4 equals 48. Let's see, 48. So our answer at the end is 7 when we simplify this expression. All right, so let's step it up a little bit. Here's example number 2. In the numerator, remembering the top is the top part is the numerator, and the bottom is our denominator. In the numerator, we have fractions. Fractions can seem intimidating, but don't be intimidated. They're just division problems. And if you really need to, you can convert a fraction to decimal and work with decimals if that's easier for you. We have our numerator and we have our denominator. I'm going to go ahead and solve or simplify the numerator first. Then I will deal with our denominator. Up here, 12 divided by 4, I know that is 3. Plus 18 divided by 6, I know that's also 3 over 5. Completely simplifying our numerator, we have 6 over 5. And I can leave this as such. 6 over 5 is a improper fraction. I can also put it as a mixed fraction. I know that there are five. There's one set of 5 and 6, and there's 1 unit left over. So 1 1/5 is our answer as a mixed number. All right, so let's do another example. Example number 3, we now have a variable in here. And of course, since this is not an equation, we're not going to solve for x. We're just going to end up simplifying and getting our answer in its lowest terms. With this, I know I have a 4 in the denominator. What can I divide 4 by to get rid of 4? Or for 4 to basically cancel out? 4 and 4. If I could get a 4 up here, that would be awesome because it could be divided out by this 4 down here. How could I do that? Is 4 a multiple of 8? Is 4 a multiple of 12? Yes. I can pull 4 out of this expression up here at the top. I have 4. 8 divided by 4 equals 2, 2x, plus 12 divided by 4 equals 3. And I'm left with this expression, 2x plus 3 times 4 divided by 4. Now I can deal with my numerator and denominator. Here, since I have 4 being multiplied by this expression and 4 also being, and down here, dividing the expression, this 4 and 4 cancel out. 4 divided by 4 is equal to 1. What's 1 times anything? The other number. So I can leave this now in its lowest terms of 2x plus 3. Technically, you could say it's over 1, but it's the same thing. What is 2x plus 3 divided by 1? 2x plus 3. There you go. All right, let's do example number 4. We're, of course, increasing the rigor again. Got to step it up. Here, I have 12x squared minus 8x. I have an x and an x in common. That's important. And then I have 6 divided by 6x squared plus 24x. Yes, everything has at least one x. So I know I'm going to be able to cancel out x from this. Perfect. Now let's look at the numbers, the coefficients. And here I have a 12. Up here in the numerator, I have a 12 and I have a negative 18. What number can be divided by 12 and 18? I know 2 can go into that. I know 3 can go into that. I know 6 can as well. And then if I'm looking down here, I have 6 and 24. Well, 2, 3, and 6 can go into these as well. And the highest number of those, 2, 3, and 6, being 6. And if I can cancel out that 6 right here, awesome. This will make my life easier. That's what I'm going to do. I'm going to take out a 6 and an x because I have a 6. 6 can go into 12 and x can go into x squared. And I'm effectively going to divide each of those by that. If I did 12x squared, just to show my logic, divided by 6x, I'll get 2x. So that goes right here. Likewise, I have negative 18x divided by 6x. I'm going to get 3. Oh, negative 3. My bad. All right. And I'm going to do the same thing at the bottom. I have 6x squared, and I'm going to divide that by 6x. And I'm just left with x. So down here, I'm going to put 6x, and then x right here inside of the parentheses. And then I have 24x. Well, 24x, hey, that can also be divided by 6 and x. And I know 6 can go into 24 4 times. And I'm left with x canceling out. That is just a plus 4. All right. So up here, I have 6x at the top and a 6x at the bottom. What's 6x divided by 6x? What's 4 divided by 4? What's 3 divided by 3? Anything divided by itself cancels out, and you're left with 1. 1 times that is 2x minus 3. So I have 2x minus 3 at the top over 1 times x plus 4. Well, that's x plus 4 at the bottom. And yeah, that is simplified. Our fifth and final example, we stepped up the rigor a little bit. In this one, we have 2 variables. We have x and we have y. And when we divide this out, we're going to end up with something remaining in our denominator. Here we have 5x times y squared in the denominator. And up here we have, of course, 2 terms, 15x squared times y plus 20x times y squared. I'm going to go ahead and simplify the numerator first. Well, I shouldn't have put that equal sign. I have this one. I know that 15 and 20 both have 5 in common. And since I have a 5 down here, it makes it even better. I'm going to factor out a 5 from each of these. They each also have an x in common. Now, this one has 2 x's and this one has 1. When I factor it, we'll see that on the other side. We'll have an x remaining for one of the terms. And likewise, each of them have a y, but this one has y squared. I'm going to go ahead and factor 5x and y from these two. So 15x squared times y, if I divide it by 5x, and I know I have at least one y here, I'll end up with 15 divided by 5 equals 3. X squared divided by x equals x, and y divided by y equals 1. So 3. Up here, I would have 5. Let me go ahead and put it here. xy times 3x. Now, I need to find that other term before I can completely close this out. For the other term, I have 20xy squared divided by 5xy. Both terms need to be divided by the same denominator when we're doing this. 20 divided by 5 equals 4. X divided by x cancels out because it's 1. Y squared divided by y equals y. So I'm left with 4y. If I multiply 5 times 5xy times 3x plus 4y, I'd come right back to what I originally started with. That's what that is. Now, looking here, I have a 5xy and a 5xy at the bottom, but this is y squared. If I divide this out, I could end up taking out a 5xy, but I'm going to be left with the y down here at the bottom. Just to draw it all out or write it all out so you can visualize it. X plus 4y over 5xy, goodness gracious, times y. And that's what that is. So I have a 5xy in the numerator, a 5xy in the denominator, and they can effectively cancel out because 5xy divided by 5xy equals 1. When I'm simplifying my expression, I come to this final conclusion. I have 3x plus 4y over y. That is my simplified expression. Okay. I hope you found this video over simplifying expressions with the fraction bar useful. If you did, go ahead and click the like button below, subscribe to the channel, and you'll also see other videos like this one. Until next time, peace out.